This discussion is IT software and data, and as I said before, these are the items that every responsible CPA should know about as they're entering the profession. The software, which consists of really two types of software. The systems software, which we know as the operating system, which is like the top traffic cop of your computer system that keeps everything functioning. And then you have utility programs that manage the data, manipulate, and control access. Then you have the application software. You know this as the term apps when you're using your cell phone. But that would also be something like Microsoft Word or Excel, or when you run PowerPoint. There are particular systems that have an application to a particular function within the company. So you could have accounts payable, you could have accounts receivable, you could have various logistics systems and general ledger systems included here. Programming languages, the first generation was simply binary coding. It took forever to get anything done. You couldn't click and point and get something completed with binary coding. It was either off or on. So you went through a system of switches to get anything accomplished. Second generation is not listed here, so you're not responsible for that. Third generation is where I really started learning my programming languages. That's COBOL, BASIC, C, and if you watched the shows, certain movies, they talk about the software systems in particular, and this is the application of that. Fourth generations are very interactive and problem-oriented, so you don't have to worry so much about the coding. And if you don't have to worry about coding, it's wonderful. You just click and you go. So these are problem-oriented, and when it's designed, we have an idea of the problems that will need to be solved. So the one that you really should pay attention to is XBRL, because XBRL is accepted by the AICPA and developed by the AICPA, and it's what the SEC uses for financial reporting. So it's streamlined financial reporting by having this XBRL. XML is a markup language. You should also know about that. What is a false statement then about XBRL? So the number here, the XBRL is freely licensed. XBRL facilitates the automatic exchange of information. XBRL is used primarily in the US. XBRL is designed to work with a variety of software packages. The one that is false or not correct is that it's used primarily in the US. It was actually developed so that there could be an interchange of information, particularly accounting information, in a worldwide setting. So you thinking about the SEC, for example, there are many companies that are required to fall into the jurisdiction of the SEC, and they may have their operations in different parts of the world. So saying it's only in the U.S. or primarily in the U.S. is wrong. And it does have to work with a bunch of different software packages, because the companies who are filing their financial statements will have different types of packages in place. Okay, this one, of course, is going to be about XML. And XML is helpful in putting data that has a structure into a text file. And then you can also extract these for use in other applications. So the focus of this is data. and that's going to be your right answer here. It's data. XML is a markup language, the markup being on the data. Next question here, a handling of payroll. What is payroll? And I think you should be able to get to this because I actually had some discussion on this, and so would you say payroll is the operating system? And you would say no. Would you say payroll is a report generator? Well, there are reports that are generated from it. That would be the actual functioning of it, but we want to know about that program. Is it a utility program? Remember, the utility programs were those that took care of basic functions. And what we're going to say about it is this is very specific. So it would be an application program. So all of these that are going to be listed here in the discussion here, C, Basic, and Fortran are all basic programs which give you the procedures. So we are going to call those procedural languages. Okay. Fourth generation computer programming languages typically have query languages which allow direct access to the computer base. So you can, XBRL is an example. That's a fourth generation computer programming language that lets you extract and analyze data that you would use for your SEC filings. So querying is the answer there. Now let's talk about binary, because I said the beginning programs were all binary. That means you'd have ones or zeros, or off or on, and it was circuitry. A byte is a group of bits, and then you go up and you have kilobytes, megabytes, gigabytes, terabytes, and all, since you only have two possible outcomes, off or on, it's really a math problem, and it's 2 raised to an exponential. So base 2 if you look at it that way. When you have a group of bytes and you put all these little bytes together, then you have the field. And when you put the fields together, as you would do in a line, you come up with what we would call a record. And when you have a bunch of records together, then you have a file. So early in the semester we were talking about this relationship, and we didn't apply it to IT. And we had an Excel spreadsheet, and we said that you could go and you could look down the Excel spreadsheet, and you called that an attribute. So similar to this sort of a concept, you can go from a small thing to a large thing. And when you have bunches of lines that are bunches of records, you are also going to call that a file. If you're going to sort out this file, then the easiest way to sort it is to have a key. And a key is a specific one of these, I'll say it, attributes that you're going to be searching on. If it's inventory, you would be searching on that inventory number, and we call that a SKU in retail. Now, it also has other applications because you might be searching according to your customers, and your customers would have a particular number, so you're searching by customer number. So there are different ways in which you can approach this. We will return to this concept. What do we call chains of binary digits? I gave it away to you. They are bytes. Okay, so chains of those become bytes, and then we had those other names which referred to the length, and the length again is exponential on base 2. The next question is going to be about the hierarchy involved. You can use what you already know, and you know then that a field and a record and then a file are the ending ones. So what's the smallest? And the smallest would be bytes. So you would, if you looked at this, you could get at the right answer from several different ways. You would know field, record, file is the right order, and so that would pretty much get you to B. And then you would also know that byte is the smallest form in that hierarchy, and the smallest form then would have to be either A or B. And so you know it's either going to be between A or B. So the bytes are the ones that really make up those are one up from the bits, and then the records are those that are comprising the file. Now, flat files are stored continuously on top of each other. What I would say that this would be these records, if you want to think of them as pieces of paper, you would have pieces of paper on top of each other. The problem you have if you have a stack of papers, and anyone who works in the office knows this, is if you happen to need one piece of paper in a stack, you have to figure out how you're going to sort through the piles to get to that piece of paper that you need. So there are difficulties with searching. And flat files are an old version of a file structure that we don't use today because information is valuable and we need to be able to get it to it in a very quick way. So we come up with this notion of having databases. And if you have a database that is based on sorting from one thing and then sorting from another thing and then sorting from another thing, you have what you call a hierarchical database. And the organization for it might be, for example, let's do everything based on customer, and then let's look at the orders that the customer has placed. So what you have then in your file is you have the customer in there once, and then off of that particular customer you have the orders. And if you went further with it, you could look at each order and you could say each order is comprised of the items that are being ordered. And so when you have a hierarchical database, if you are going to see what it looks like or have a kind of conceptual view of the thing, it would look like a tree. It would a tree with branches, and I would take it even further to say you have a large branch, a smaller branch off that until you do get out there to the leaves. In contrast to this, you have relational databases, which are comprised of tables with columns and rows. And the columns are, we're returning to our old discussion of this, the columns are the attributes, and then the rows in this are the records. And so we have to have a process to reduce the number of elements that we have because it can get out of control. And so you tend to say that there is only a certain value that you can have for each one of the data elements. Object-oriented databases permit us to actually store things other than, say, data. And this becomes important today. Which one of the following correctly depicts the hierarchy of storage commonly found in computerized databases from the least complex to the most complex? Okay. What, in other words, would you say occurs when you have a complex database? And if you have a complex database, you would hope that data redundancy will be reduced, because if you have one of these databases, you don't need to list, say, the customer number or customer name multiple times. You can have everything related to that one customer. and automatically go to the specifics related to that one customer. So if we're thinking about this, if you are going to go back and you were going to think about files, for example, you would have multiple pieces of paper that were related to that particular customer, perhaps in a stack. If you went to a very complex system, you would only have that customer once. And once you got a hold of that customer, you would find all the information that relates to that customer. And another way of looking at it then is if you have a database system, you have one location which is going to show each one of the data items. So you don't have to go, there is not what we call data redundancy. Because if you have data redundancy, it takes up storage space and it makes your sorting and searching more difficult. A database is merely a collection of related files. It is not proper to say it's a real-time system because you can use a database in real time or in batch processing. It's possible to do that. It doesn't have anything to do with the computer terminals, and it is not necessarily essential for the storage of large data sets. It just makes it easier to store more information and take up less space, and for you again to be able to sort, search, and find what you need easier. So it is a collection of really related files. However, I want to say it's not the old style file structure with the papers again on top of each other. It's the fact that you can look at one thing and you can see everything that's associated with that one thing. Database management systems are the set of programs that help you maintain the integrity of the database. Because the database is a collection and things are related in a certain way, you're getting back to the notion of garbage in, garbage out. You want to protect it. You want to make sure it's right. And there's another thing which we have with the database management systems, which is that the user who is using the database doesn't have to know the hierarchy of the data to work with it. So the database is very user-friendly, and different users can have different views of the same database, and their particular view of the data is called a schema or a schemata. And so different users within that, we say they have subschematas. In addition to saying that, we also have different terminology that is used for it. There is data definition language, which tells us what the specific data elements are that we are going to include. Data manipulation language that lets you change the data. And you can have the database management system stored at multiple locations. And what we are saying here is then you can actually access the database from different locations. If you were in one store and you have your inventory database for your store, maybe you want to look at what is at another store, and you can also access that to see if what is necessary for a customer's order could be filled from another store. A data dictionary says who is responsible for a particular data element. It also talks about what you can put in there and how it should be formatted. Now we're moving from the database to talking about applications. And these are the specific applications that you might need in your company. So what about growth? What about the different things we might need to do in the future? The participants in all of this are the stakeholders, the end users. Then we have a steering committee that's going to review everything. And then we have a project team that works together, and upper management is going to be determining the resources that are required. So we are developing here a new application, or we're working on the maintenance of the existing one. What we want to bring home here is this, like in AIS, if you have a change in a business process, you are also going to have likely a change in IT. You're going to have a change in application development that needs to happen. Along these lines, then, you have to decide, are you going to build a thing, or are you going to buy the thing? And recently, in our previous PowerPoint, we had a situation where we're going to the cloud. And if we go to the cloud, we don't really make the decision to build. You just say, no, we're not building it. We are using the cloud, and we're using someone else's software application that's been developed. The other option is to buy it, and I'd say the cloud is somewhere in the middle, because with the cloud you don't really buy it and use it. You are paying according to your usage of it, so it's a usage fee. So in the cloud it's a usage fee. So we have something that's in between building and buying now when we use the cloud. If you're going to buy it, though, you're going to buy something that you're going to hope that they are going to provide an update to it. So if there's a flaw in security, or there's some flaw that's becomes apparent within that application, you would want to buy it with the knowledge that it will be updated and corrected. Now, the system design life cycle, it says that after we have determined that we need a new system, the first stage is going to be the feasibility and studying that and the planning associated with it. And we have to be specific about what we want it to do. We're going to submit the proposal to a steering committee. The steering committee is going to look at the feasibility and see if it's really possible to do everything. And they're going to determine whether it's possible to do it, whether we should go forward. And if we do go forward and we do design it, we need to have flow charting done. We need to talk about the hardware that is associated with it. And this all has to be done. After the design, and you build it, you develop it, then you're going to test it. And you usually see testing which is done while it's being built, because if there's a flaw at this point, then it carries over to the next levels of the development. And then I worked in this area in accounting. And we worked with the steering committee to develop and fix our accounting to really reduce the amount of work and reduce the errors that we were seeing in the work that was being done. When we did this, then the group that was creating this or designing this new application for us came back to us and said, this is what we have done. And we were responsible then to either accept or reject what was there. And we would say, we need this done. You didn't really address this. There are problems here that need to be covered, and you need to do some more work. And oftentimes there's a communication issue between the accounting department and the IT development. So there will be an audit of some sorts done. We'll talk about the different ways you can phase in new systems in a moment, but there needs to be an audit done to make sure that everything that we said we wanted to accomplish is accomplished. And you're talking about accounting and you have a new systems application that goes into effect, there's ramifications. It could be your managerial reports will be wrong. It could be your ledger is going to be wrong. There's various issues there. So you have to have a way to audit it and see that it actually does what you had proposed it would be doing. Now, when you are converting in the process of converting to a new system, you have accepted the new system, you believe it's going to do what you want it to do, and there's some reliance because you have an audit of some sorts done. Well, parallel is when you run your old system and your new system at the same time. And this is also a discussion when we're talking about a particular application, and I should be careful in how I say that. So you could have two different programs, for example, and you might be wanting to go to the new program. Well, how can you be sure that the new program works the way the old program works? If you went for a whole month and you ran everything through twice, and that is you ran it through on your old system and you run it through on the new system, the new program if you want to call it that. Well, then in the end you could compare. And if we're talking about general ledger, you could look at your general ledger. Is the general ledger the same? Now, cutover means you basically change from one system to the other. Okay, tomorrow we're on the new system. With pilot, you will try one unit first and then see how that is. And so a pilot study is really a practice to see if things are working or if they're not working. When we talk about phased, you use one group at a time until everything is on the new system. I have seen in universities where this is done. So arts and sciences, for example, may be on the new system. And then we'll bring in accounting or business. And then maybe we'll bring in the tech center. So you have one group that goes on to the new system, then another group. Because a part of doing this is also training your employees. So you change from one thing to another. The screens that they're inputting data may look different. The output in the terms of reports may look different, and it's because you have, again, a new system or a new way of doing things. This could be a new application software, by the way, or it could be changing over your complete computer system to a new system. So, parallel is going to be costly, right? Because you're going to be running two at the same time. You're doubling your work. Cut over, or I'd say cut off from one to another is quick, but you probably want a little assurance that it's working right. And so the pilot and phased are ones that are kind of in between, if you will, as far as the riskiness involved. Pilot, it takes a while because you're gradually you're looking at this and seeing whether it really worked for that particular unit. And it seems you'd think, well, phased is the same as pilot. But no, phased means that you are actually having a plan, and your plan is to bring this group, and then this group, and then this group, and then this group, and you have that methodology in place. Pilot means you're just doing a try to see if it works. Program changes then. When you have a particular change to a program, an application, say, or any type of program, what you're going to do is put the code in an area called the sandbox. And when you're in the sandbox, then you make copies to the code within the sandbox. You're going to test that new version on test data. And production data is the data that is actually used to provide output. So you're not going to use your actual, we also might call live data. You are going to use a sample of data, you're going to test it, and you're going to see what happens. So we have this input, and if we typically run our programs, we get this output. So let's put this input into our trial version that has been developed in the sandbox and see what the output is. We are going to show then the user, the one that needed the results here, what happens, and they're going to get them to either approve or not approve. So then it comes out of this trial area called the sandbox and gets brought back in and is used. Now, operations personnel are the people that run everything day to day. They do not do the programming. The programming is done by separate individuals. So operations and programming is your type of segregation of duties which you have within this. When we create this working version of a new system, it's called phototyping. And when we use the computer to apply the design and development, we call it this case. End user computing. End user computing, or EUC, is the development of systems by the user versus the IT development. And this is when the end user develops what they need for themselves. The problem with this is you might have also think of this from our previous PowerPoint. We were calling this decentralization. The problem with decentralization is everyone is doing their own thing, and therefore you have problems. You have problems associated with unauthorized access because your security is inadequate. You don't have good backup or contingency planning. So you don't have a broad overall review of everything, and it's because everyone is doing what they particularly believe they need to do in developing their own systems. And because everyone is doing it, they're all accomplishing their own specific needs. You don't have an audit trail, because remember, an audit trail takes us from the beginning point to the ending point in a cycle. And often the end user is at only a particular point in that cycle. So if we were talking about purchasing of inventory, for example, you would have had the purchase order and you would have gone all the way through invoices and receiving. Well, if you particularly you are the end user in receiving, you take care of your receiving and you forget about all the links that need to be established. Or maybe you're the one, a better example would be in the purchase decision. Once the purchase decision is made, that's their decision, they make that, and they think, well, I'm done. But no, that's not the end of it, because when you look at it holistically, you have to realize there's an audit trail, there's a number of steps that go along. So this is a problem when you have end user development, it says end user computing, versus having a comprehensive IT department that's going to develop an overall system to handling your AIS.